Welcome back to Talk Tensors, everybody. Today, we're taking a deep dive into AI RAN, transforming RAN with AI-driven computing infrastructure.
Oh, this is a paper that's really making waves, yeah.
In both the AI and the telecom worlds.
A really interesting intersection, actually.
Yeah, this paper's not just proposing some new tech, it's suggesting a fundamental shift in how we think about networks.
It really is.
So the core idea here is AI RAN, which is basically integrating AI and RAN workloads onto the same infrastructure. And traditionally, these have been separate, dedicated systems.
Yeah, and that separation has really become a bottleneck. As we demand more from our networks, faster speeds, lower latency, support for these complex applications.
Like Edge AI.
Yeah, AI. Yeah.
This old way of doing things just isn't cutting it anymore.
No.
So AI RAN is kind of like killing two birds with one stone, right?
Yeah.
Boosting both AI capabilities at the edge and making the network itself smarter.
That's the promise, and the paper does a really good job of breaking down the different ways that this integration can happen.
Right.
They talk about AI for RAN, using AI to improve those existing RAN functions.
Okay.
So imagine things like optimizing beamforming in real time to avoid interference, or dynamically allocating resources based on where the demand is highest.
So it's like giving your network a brain upgrade.
Yeah.
Making it more efficient and responsive.
Exactly. And then they take it a step further with this AI on RAN, where you're actually hosting those AI applications directly on that RAN infrastructure.
Oh, wow.
And that opens up a whole new world.
A whole new world of possibilities, yeah.
Yeah, think about personalized AI assistants.
Okay.
Real-time image recognition for those security cameras. Or even localized AI processing for all those Internet of Things devices that everybody's talking about. All running right there at the edge, right where the data is being generated.
But the real mind blower for me, at least, is this concept of AI and RAN, where AI and RAN workloads are actually sharing resources dynamically.
Yeah. Now that's where it gets really interesting, especially from a technical perspective.
Yeah.
We're not just running these workloads side by side. We're enabling them to actually cooperate and adapt to each other's needs in real time.
Oh, wow.
Yeah.
So it's like a symbiotic relationship. They're both benefiting from sharing the same resources, leading to better overall performance and efficiency.
Precisely. And the paper actually dives into the nitty-gritty of how to achieve this dynamic sharing.
Okay.
Outlining a reference architecture that includes things like multi-tenancy and resource allocation techniques like multi-instance GPU, MIG.
Now, for our listeners who might not be familiar with MIG, could you break that down a bit?
Sure. Think of a GPU as a really powerful engine.
Okay.
MIG allows you to partition that engine into smaller, independent engines, each one dedicated to a specific task.
Got it.
This allows different workloads, in this case AI and RAN, to actually share the same GPU without interfering with each other.
It's a key enabler for this AI and RAN because it ensures that both workloads get the resources they need when they need them.
Okay. That's a great analogy. It makes it much easier to grasp.
Good.
But before we get too deep into the technical weeds, let's kind of step back and look at the historical context here.
Sure.
Why is this concept of AI RAN even emerging now?
Yeah, well, it's not coming out of nowhere. We've been seeing this trend of convergence happening for a while.
Okay.
On one hand, you have this exponential growth of data being generated by all these mobile devices and IoT sensors, which is really driving the need for more powerful and intelligent networks.
And on the other hand, you have this explosion of AI applications that require massive computational resources.
Particularly at the edge.
Particularly at the edge, yeah.
And these traditional RAN architectures, they just weren't designed for this kind of workload.
Right.
They're struggling to keep up with the demands for speed, latency, flexibility that these new applications require. So AI RAN is, in a way, a response to this perfect storm of technological advancements. And evolving user demands.
Yes, exactly. It's about recognizing that the future of networks is intelligent, adaptable, and AI is really the key to unlocking that future.
Now, the paper goes on to discuss some of the key requirements and enablers for making AI RAN a reality. It's not just a matter of wishing it into existence. There are some pretty significant technical hurdles to overcome.
For sure. The first hurdle they highlight is the need for a robust and accelerated computing infrastructure.
Right. We're talking about serious hardware here,
Yes.
capable of handling both the massive data processing demands of the RAN
Right.
and the complex computations required for AI,
Yeah.
especially for things like model training and inference.
Exactly. And it's not just about raw processing power. The paper emphasizes the importance of a software-defined cloud-native design as well.
For our listeners who might not be familiar with those concepts,
Sure.
could you give us a quick ELI 5?
Okay, so imagine building a network like you would build with Lego blocks. Okay. In a cloud-native environment, each network function is like a separate Lego block, self-contained and modular.
Okay.
These blocks, often called cloud-native network functions, or CNFs, they can be easily assembled, reconfigured, and scaled up or down as needed.
Okay.
This approach provides that flexibility and agility that is needed for AI RAN.
So instead of having a rigid monolithic network architecture, you have a more adaptable system
Exactly.
that can evolve and respond to changing demands. I like that analogy.
Good. And along with CNFs, concepts like microservices and CI/CD continuous integration and continuous delivery also come into play.
Okay.
Microservices break down complex applications into smaller independent services that can be developed and deployed more easily.
Okay.
And CI/CD allows for these frequent updates and improvements to the network, ensuring it stays ahead of the curve.
So it's all about making the network as agile and responsive as the applications that it's supporting.
Exactly.
But even with all this flexibility, you still need a way to orchestrate everything, right?
Yes, you do.
To make sure all these different pieces are working together in harmony.
Absolutely. And that brings us to another crucial requirement: a unified orchestration platform that can intelligently manage both the communication and computing resources of this AI RAN system.
It's like having a conductor for an orchestra, making sure all the instruments are playing in sync and creating a beautiful symphony.
That's a great analogy.
And the paper makes a strong case for using AI itself to drive this orchestration process.
It does.
AI algorithms can analyze network traffic, predict demand, and dynamically allocate resources to ensure that optimal performance for both RAN and AI workloads.
Precisely. It's AI managing AI, which seems a bit meta,
It does, yeah.
but also incredibly powerful.
But to make this intelligent orchestration work, you need more than just a platform.
Yes.
You need AI baked into the very fabric of the RAN infrastructure, right?
Absolutely. The paper emphasizes the importance of native AI support,
Yeah.
meaning that AI capabilities need to be embedded throughout the RAN, from those radio units at the edge to the core network functions in the cloud.
Okay.
This allows for real-time decision-making, automation, and optimization across all levels of the network.
And to ensure these AI integrations are safe and effective, the paper highlights the use of network digital twins.
Right.
These are virtual replicas of the physical network that allow you to test and validate AI models before deploying them in the real world.
It's like having a sandbox for your AI, where you can experiment and refine your algorithms without risking any disruption to the actual network.
I love that.
Right.
Now, the paper doesn't just stop at theory.
Right.
It also presents a concrete reference architecture for AI RAN. This architecture shows how the different components, from the radio units to the core network,
Yeah.
all fit together to create this unified system.
They even provide a proof of concept,
Wow.
demonstrating how an LLM-powered chatbot and a 5G RAN workload can run concurrently on the same server.
Okay.
Using this architecture, it's really a powerful demonstration of the potential of this technology.
That's amazing. Okay, we've covered a lot of ground here, from the basic concepts of AI RAN to the technical requirements,
We have.
and even a glimpse of what's possible in practice. I'm already excited to see where this technology goes next.
Me too. And the paper itself hints at some really fascinating research directions for the future.
Well, that sounds like a perfect segue into our next segment, where we'll dive into those research directions and explore some of the bigger picture implications of AI RAN. Stay tuned.
Welcome back to Talk Tensors. Before the break, we were really digging into the core concepts and architecture behind AI RAN.
Yeah.
Now, let's kind of shift gears a bit and examine the broader context here.
Okay.
What's happening in the industry? What does the future hold for this technology?
Right. We talked about all these technical possibilities, but is anyone actually working on making AI RAN a reality, or is this just ideas on paper?
Well, one of the most encouraging things I've seen is the emergence of some real-world AI RAN solutions and initiatives. So you have companies like Arnon Networks with their AMCOP platform and SoftBank with their AI trays framework,
Okay.
they're already developing and deploying AI RAN systems.
So these aren't just research projects anymore.
Mhm.
We're seeing actual companies investing in and building this technology.
Absolutely. And it's not just individual companies either.
Oh.
We're also seeing the formation of industry alliances focused specifically on AI RAN, like the AI RAN Alliance and the Global Telecom AI Alliance.
Okay.
This kind of collaboration is crucial for driving standardization, interoperability, and ultimately the widespread adoption of AI RAN.
So there's real momentum building behind this technology.
Yes.
It's not just some niche research area anymore.
Right. And that makes sense when you consider the potential impact.
Yeah.
It's not just about making networks faster, more efficient.
Uh-huh.
AI RAN could actually be a game changer for a whole range of industries.
Okay, so we're talking about applications beyond just telecommunications then.
Huh.
What are some of the other sectors that could benefit from this?
Well, think about smart cities.
Okay.
AI RAN could enable those real-time traffic management systems that optimize traffic flow based on data from sensors and cameras,
Okay.
reducing congestion and improving safety.
Interesting.
Or imagine an industrial IoT environment
Okay.
where AI-powered predictive maintenance systems could analyze data from connected machines to anticipate and prevent failures
Gotcha.
before they even happen, saving companies a lot of time and money.
Those are some pretty compelling examples. It sounds like AI RAN could be like a key enabler
Yeah,
of a more connected and intelligent world.
exactly. And that's really just the tip of the iceberg.
Wow.
The paper also discusses the potential for AI RAN to revolutionize edge AI applications,
Okay.
from healthcare to retail to entertainment.
Wow.
As we bring more and more computational power to the edge, the possibilities become almost limitless.
It's exciting to think about, but of course, no emerging technology is without its challenges.
Right.
The paper does touch on some key areas for future research, right?
Yes, and they highlight some important hurdles that we need to overcome.
Yeah.
One of the biggest challenges is developing those more advanced orchestration and control frameworks.
Yeah.
As these AI RAN systems become more complex, with multiple workloads sharing resources dynamically,
Right.
we need sophisticated algorithms
Yeah.
that can seamlessly manage this complexity,
Mm-hmm.
ensure optimal performance, and adapt to these ever-changing demands.
It sounds like a very delicate balancing act, ensuring both the RAN and AI workloads are getting what they need
It is.
when they need it without kind of compromising the overall performance.
Exactly. And it's not just about managing those resources.
Mhm.
We also need to think about latency, reliability, and energy efficiency.
Of
They're all
course.
critical factors that will determine the success of AI RAN
Yeah.
in real-world deployments.
Right. It's a reminder that AI RAN is not just a theoretical concept,
No.
but a practical engineering challenge requiring careful consideration of all these factors.
And that's why standardization and interoperability are so important. Yeah.
The paper emphasizes the need for those open standards and interfaces that allow different AI RAN solutions to actually work together seamlessly.
Yeah.
This will prevent vendor lock-in,
Yeah.
foster innovation, and ultimately drive down those costs.
It's like ensuring all the different pieces of the puzzle fit together smoothly, regardless of who made them.
Exactly.
Yeah.
And finally, the paper stresses the need for real-world testing and validation.
Okay.
We need comprehensive test beds,
Yeah.
standardized benchmarks, and pilot deployments to move AI RAN from the lab to the field.
Right. It's one thing to demonstrate the feasibility of AI RAN in like a controlled environment.
It is.
But it's another thing entirely to prove that it can work reliably and effectively in the real world with all its complexities and unpredictability.
Absolutely. And that's where the research community has such a crucial role to play.
Yeah.
We need to develop those rigorous testing methodologies, collect real-world data, and conduct these large-scale trials to fully understand
Yeah.
the capabilities and limitations of AI RAN. So it's a journey of continuous learning and improvement.
Exactly. And the paper itself is a valuable contribution to this journey,
Okay.
providing a solid foundation for understanding the core concepts,
Yeah.
challenges, and opportunities of AI RAN.
Well, that brings us to the end of our deep dive into the paper itself.
Right.
But before we wrap up, we always like to indulge in a little bit of speculation.
Sounds fun.
Time for our Novel Notions segment,
Okay.
where we explore some pretty outlandish, but potentially groundbreaking ideas inspired by the research we've been discussing.
I like it.
Well, this paper got me thinking about the potential for AI RAN to not just improve existing applications, but to enable entirely new types of experiences that we haven't even imagined yet.
Like what?
What if AI RAN could actually blur the lines between the physical and digital worlds,
Okay.
creating truly immersive and interactive environments?
Now, that's an intriguing thought. Are you thinking something like augmented reality or virtual reality applications?
Exactly.
Mm.
Imagine a world where your network could understand your physical surroundings,
Okay.
your preferences,
Yes.
even your emotions,
Mm-hmm.
and then use that information to create these personalized dynamic experiences
Yeah.
that blend seamlessly with the real world.
Okay, I'm following you.
Imagine walking down the street and your AI RAN-powered network recognizes that you're passing by a bookstore
Uh-huh.
that you mentioned wanting to visit.
Mm.
It could then overlay personalized recommendations onto your field of view, highlighting books you might enjoy,
Right.
or even directing you to a specific section based on your interests.
That's a pretty cool idea.
Or imagine attending a concert where the AI RAN network is actually adapting the lighting and sound
No.
based on the collective mood of the audience,
Yeah.
creating a truly immersive and interactive experience.
Those are some pretty wild ideas.
They are.
But I can see how AI RAN could make them possible.
Of course, there are a lot of technical and ethical challenges to consider here. Privacy concerns,
Yeah.
data security, the potential for manipulation. These are all issues that would need to be very carefully addressed.
Right. Important to remember, with great power comes great responsibility.
Right.
As we explore the potential of AI RAN to create these immersive experiences,
Yeah,
we need to do so thoughtfully and ethically.
absolutely. But it's still fun to speculate, isn't it?
It is.
To imagine the possibilities that this technology might unlock in the future.
It definitely is. And who knows?
Yeah.
Maybe some of these seemingly far-fetched ideas will become reality sooner than we think.
Well, on that note, we'll wrap up this episode of Talk Tensors.
Okay?
We've explored the core concepts of AI RAN, its potential impact
Mm.
on various industries, and even some speculative ideas about the future.
Hmm.
It's clear that this is a technology with immense potential to transform our world. Welcome back to Talk Tensors. We've been deep diving into AI RAN, this fascinating convergence of AI and radio access networks. We've talked about the what and the why,
All right.
but now I'm really curious about the how WAN. What are the concrete steps researchers and engineers are taking to make this vision a reality?
Well, the paper does highlight some key research directions that need to be explored further.
Uh-huh.
And one of the biggest challenges, as we've touched on,
Yeah.
is the need for more sophisticated orchestration and control.
Right.
As AI RAN systems become more complex, we need smarter ways to manage resources
Of course.
and ensure smooth operation.
It's like conducting an orchestra where some musicians are playing classical music and others are jamming to jazz all at the same time. You need a conductor who can keep everyone in sync, but also adjust the tempo and dynamics on the fly.
That's a great analogy. And in the case of AI RAN, that conductor needs to be an AI-powered orchestration platform.
Right.
This platform needs to be able to monitor network conditions in real time, predict future demands, and dynamically allocate resources
Okay.
to ensure that both the RAN and AI workloads are humming along smoothly.
And it's not just about allocating resources, right?
No, it's not.
We also need to consider latency, reliability, and energy efficiency.
Right.
These are all really critical factors for real-world deployments.
Imagine a self-driving car relying on AI RAN for real-time navigation and decision-making. Any delay or disruption in the network could have some really serious consequences.
Of course.
So robustness and reliability are paramount.
Right. And energy efficiency is also a major concern, especially as we deploy more and more AI-powered devices at the edge. We don't want to create a system that's so power-hungry that it's unsustainable.
Exactly. So researchers are exploring new algorithms and techniques
Sure.
to optimize resource allocation, reduce latency, improve reliability, and minimize energy consumption. It's a multifaceted challenge
Yeah.
that requires a pretty holistic approach.
Now, another key research area mentioned in the paper is standardization and interoperability.
Right.
With multiple vendors developing AI RAN solutions,
Yes.
we need to make sure they can all work together seamlessly.
Imagine trying to build a house where the doors come from one manufacturer, the windows from another, and the plumbing from yet another, and none of them are designed to fit together. It would be a disaster.
A very expensive and frustrating disaster.
Exactly. That's why establishing open standards and interfaces
Right.
is crucial for the success of AI RAN. It allows different vendors to build components that can be easily integrated, fostering competition,
Okay.
innovation, and ultimately a more robust and adaptable ecosystem.
And of course, we can't talk about research without talking about testing and validation.
We can't.
We need to move beyond simulations and lab experiments and see how AI RAN actually performs in real-world settings.
Absolutely. We need to create those comprehensive test beds,
Okay.
develop standardized benchmarks, and conduct large-scale pilot deployments
Right.
to really understand the capabilities and limitations of AI RAN.
It's like taking a new car for a test drive. Before you buy it, you want to see how it handles on different roads,
Exactly.
in different weather conditions, with different loads.
Yeah.
You want to make sure it's reliable and safe before you commit to it.
And the same principle applies to AI RAN.
Yeah.
We need to put it through its paces in real-world scenarios to make sure it lives up to its promise.
Now, speaking of promises, this paper has certainly sparked our imaginations about the future of AI RAN. But before we wrap up, I want to kind of revisit our novel notions segment.
Sure.
From earlier, we were speculating about how AI RAN could blur the lines between the physical and digital worlds,
Yeah.
creating those truly immersive and interactive experiences. Any further thoughts on that?
I've been mulling that over, and I think one of the most exciting possibilities is the potential for AI RAN to create personalized and adaptive learning environments.
Okay.
Imagine a world where your network could analyze your learning style, identify your strengths and weaknesses, and tailor educational content specifically for you.
It's like having a personal tutor who lives inside your network,
Yeah.
constantly adapting to your needs and guiding you on your learning journey.
Exactly. And it's not just about customizing the content either. It's also about creating a more dynamic and engaging learning environment.
Okay.
Imagine a virtual classroom that adjusts the lighting, the temperature, the background music,
Wow.
even the virtual avatars of your classmates
Okay.
to create an optimal learning experience
Yeah.
based on your mood and preferences.
That's incredible. It would totally revolutionize the way we learn both inside and outside the classroom.
And think about the implications for professional development.
Yeah.
Imagine a world where your AI RAN-powered network could recommend courses, provide personalized feedback on your work,
Okay.
and even connect you with mentors and collaborators based on your skills and goals.
It's like having a career coach and a personal development guru all rolled into one.
Exactly. And the possibilities extend beyond just education and professional development.
Right.
AI RAN could also enhance our social interactions, our entertainment experiences, and even the way we interact with our physical environments.
It's a future where technology seamlessly integrates with our lives, augmenting our capabilities and creating a more personalized and engaging world.
It's a future that's both exciting and challenging.
It is.
We need to be mindful of those potential risks and ethical considerations as we develop and deploy these powerful technologies.
Of course.
But the possibilities are truly inspiring.
Well said. Well, on that note, we'll wrap up this episode of Talk Tensors. We've explored the fascinating world of AI RAN,
We have.
from its technical foundations to its potential to transform industries and even reshape the way we learn, work, and interact with the world around us.
It's been a really stimulating discussion.
As always, we encourage our listeners to delve deeper into this topic, explore the links in the show notes, and share their own thoughts and perspectives. The future of AI RAN is still being written, and we all have a role to play in shaping it. Thanks for tuning in, and we'll see you next time on Talk Tensors.